All right, so now we're into the curriculum objectives for the first unit, and we're going to talk about systems of equations. All right, so first of all, what the heck is a system of equations? All right, so in math, whenever we're talking about a system, we refer to when we have multiple different equations, we want to solve them at the same time. All right, so we have these kind of, for our class right now, it would be two different equations. We're going to solve them at the same time, and we'll kind of see what that means in a second. Because there's two different equations, it looks something like this. Because there's two different equations, we'll have an x and a y value, which means in an ordered pair, x comma y to be a solution. So it's a little bit different than solving just an equation by itself, where you just get like x equals 2. Instead, every equation is going to have two different parts to it. And when we say it's a solution, if when we plug it into the equations, it solves all the equations that we have. All right, so let's see what I mean. First of all, what does a system look like? So it's basically these two different equations, and I normally connect them with one of these curly brackets to represent that these aren't two separate problems. It's one problem where we want to solve both of these at the same time. And for right now, we're just going to ask, is this a solution to the system? So is the point 2, 3 a solution to the system? Well, if it is, if I plug in my x value 2 and my y value 3, both equations should be true. So let's try with the first one. X is 2, y is 3. All right, so let's see if this is true. 3 times 2 is 6, 2 times 3 is 6, and 0 is not equal to 1. So 2, 3 does not solve, oh, and I even put a minus sign. This should be a plus sign, so it's even worse because it's not 0, it's 12. 12 is definitely not equal to 1. So 2, 3 is not a solution to the system because it doesn't solve that top equation. All right, what about the point -1, 2? So do the same thing. X is -1, y is 2. 3 times -1 is -3. -3 plus 4 is 1, and 1 equals 1, that's good. All right, that alone is not enough to mean it's a solution. It has to solve both at the same time. So you also have to check the next equation. -2. All right, 5 times -1 is -5. -5 minus 2 is -7. And again, we get something that is true, so that's also right. So there's one point, -1, 2 solves both these equations, which means -1, 2 is a solution. So that one is, this one is not. All right, so whenever we're asking, is something a solution to the system? Again, it's important we're talking about a system. It has to solve multiple equations at the same time. All right, so here's your turn. Is 1, 3 a solution to this system? And the answer you should have got is yes. If I plug 1, 3 into both of these equations, then I get equations that make sense. The left-hand side is equal to 9, the left-hand side is equal to 2. And since it works for both equations in the system, it is a solution. All right, the other thing we're talking about linear equations here, which means we could graph them and get these lines. All right, what is the solution to this system? All right, we would have equations and these lines and everything. All right, but here I just gave you the lines. What's the solution to the system? So this red line, this represents all the solutions to one linear equation. This blue line represents all the solutions to a different linear equation. Well, what is going to solve both at the same time? Well, if red solves all the one, blue solves another, the point that solves both is right here where they intersect. So the place where these two lines intersect is going to be a solution to the systems because it's on the line for both equations, which means our answer here, we're just basically asking ourselves, what's the coordinate of that point? We went left 1 up 2. It's the point -1, 2. All right, so that's all you have to do if you have the graph of a system. Figure out where those two lines intersect, and that's your solution. So what's the solution to this system? All right, try to figure this one out on your own. And the answer is 1, -1. All right, they intersect at that green point, and we went right 1, down 1 to get to that point, 1, -1. So really the only mistake students tend to make on this one is just either mixing up the points x and y or not forgetting a negative sign. All right, but if you have the graph of a system, it is where those two systems intersect. All right, it's going to give you the solution. And your multiple choice question, very similar. What is the solution to this system? So this was a kind of short one. You're just checking values and looking at intersection points to figure out if you're solving these systems, which there's two equations at the same time.